Here the focus is on the waiting time. And to calculate the waiting time, we have the related formula. Uh, the waiting time is the difference between arrival time and service start time. So, since the service start time cannot be smaller than arrival time, so the minimum amount that it can get according to the system we defined is 0, and it is the minimum amount, so it can be 0 and greater numbers. So just the formula we need to put here is, as you can see, it is E4 minus D4, that is service start time minus arrival time. So service start time in this line, it is E4, as you can see, and I'm referring to it now here, as you can see, and I'm referring to it, E4 minus D4. Service start time minus arrival time, and here for example it is 0 0 0, but it shows for example scarf 4 needs to wait 2.6. And remember, the average, the standards that they have in the company is 1 minute. If the average waiting time is smaller than 1 minute, that's okay. It means that the number of inspection stations they have is enough. Now I'm gonna shift to the Excel file, and we are gonna do it over there for 1000 times. So when I shift to that part, I'm gonna cover this slide that says let's run our simulation as many times as it reaches 1000 times, and it would be something like this. Here we have the Excel time, and I'm gonna put the waiting time. Before we do the waiting time, if I ask you about the waiting time being increasing or being something fixed, what would be your answer? The correct answer is this. Both scenarios could happen. I mean, if in a system the service rate is higher than arrival rate, the waiting time is not increasing, and it is something under control, and it is the thing that we expect from regular systems. For example, when you want to go um, in a bank, okay, and what is the waiting time between 8 a.m. and 9 a.m., 9 a.m. and 10 a.m., 10 a.m. and 11 a.m.? It is not like that. Later you go, you have to wait longer. Maybe there are some hours that they are busier and you have to wait longer, but it is not like that. More you continue the system, the waiting time increases. In a healthy queue systems, it is the case, it is the goal. But in the systems that arrival rates are higher than service rate, of course that later you go, you have to wait longer. So here I'm gonna write the formula, and after that I'm gonna extend it to the remaining 1000 cases, or 999, because when I do 1, the remaining would be 999. So here the waiting time equals service start time minus arrival time. For the first customer, it is 0. Why? Of course, because the first customer wins, or when the first scarf go into the inspection section, there is no other scarf, so there should be no waiting time. But after that, from scarf 2, there is a possibility of waiting time. Let's check, for example, for the first 10, you see some of them are gonna wait. But the thing that is important for us is the average of waiting time. So we have this thing. Now I can tell you our simulation model is done 95%. The remaining 5% would be some sort of analysis about these results. Now we have all the results, we have everything that can help us with the decision making. So for the remaining 5%, we're just gonna use all these things we got for the decision making. What have we gotten so far? And it was the table that we just discussed, and it is the simulation run of 1000 cases, 1000 example. What more we need to do to claim mission accomplished? We need to calculate the average of the outcome, the average of the waiting times that we calculated. And if the average that we are calculating is less than 1 minute, it means that the system is fine and just one inspection operator, one inspection station would be enough. Otherwise, we need to add to the inspection operators. So now again, we need to go to the Excel file, but I have the results here. As you can see, the average, according to the calculation I have, is 1.54. Standard deviation is not important here. And I'm gonna also do the calculation with the Excel file I have. Just this average would be enough for the calculation, and since it is 1.54 according to this result, it is not acceptable. But now I'm gonna check it with the Excel file and we can confirm the results. Okay, we have average and we have standard deviation. Here, let's need average. You see the average that we are getting here with this Excel file is also close to the one that we saw with the PowerPoint, and that's the it is not magical, but I always call it magical because it is all about random numbers. But if you do it with different computers, but the systems still matter, not the computer system. For example, the Excel software that you are using, because now we are using Excel for this simulation. If you are using the platform of Excel, because the way they generate the random numbers or those things can create a little bit differences in the results, not in general, because we are using 1000 of runs, so it is still sensitive to the software that you are using, not again that much. And about the standard deviation, if we do it, we have this standard deviation here that again makes sense. F9. You see, for this one, we have the average of, now I'm refreshing the page. We have the average of 1.9 and a standard deviation is 2.5. The standard deviation is very similar to the one that I showed you in the PowerPoint. The average is higher. Now this one, it is 1.2, 1.6. You see, all of them say that we need to add another inspector. That's the reason I'm telling you it doesn't have effect on the results, because now I run it. All of them, oh, even we got 2.2. Then I'm refreshing the page, and now you can see all of them are above 1 minute. So I'm very sure, I'm very confident when I say that absolutely according to the standards of this company, they need to add another inspector. But imagine in a situation that when I refresh it, sometimes it gives me numbers that are 1.2, sometimes it gives me the numbers that are above 1, and sometimes it gives me numbers that are below 1. In that situation, you cannot make the decision, and you need to change the assumptions of your modeling, because simulation must be done in the case that when you are giving the answer, you are confident based on your analysis. And again, I explain it to you. See, the point that I'm telling you, I refresh my page many times. You see all of the answers I'm getting, although all of them are random numbers, all of them are above 1. So I can announce it that according to this situation that you are giving me, absolutely you need to add another inspection operator, another inspection station. Okay, so because each one of them that I run, it is like 1,000 scarf. So for example, when I run it 10 times, it is 10,000 scarf, and it says it is the case. So I would be pretty sure that in real life, based on this assumption that you see in front of you, based on these settings, the waiting time would be above 1 minute. But what if, but is there any other situation? Yeah, sometimes it is above 1, sometimes it is above, sometimes it is below 1. In that situation, you cannot make the decision. So even if you make the decision in that situation, that decision is not as much reliable. And this type of results that I got here, and I'm showing you, and your results must be in this way, that although there are trivial differences between the numbers, I mean average and ST, but they all are on the same plate in terms of decision making. And again, the other way, if all the averages that you get are below 1, again, it's very good. You can make the decision. Let's do, in the remaining time, that is about less than 2 minutes, let's run this example for 10,000 and see what will happen. Now you see I have run the simulation for 10,000 times, and it is not a big deal. I just drag it for more situation. Now, when I calculate the average and also standard deviation, the results are more reliable than 1,000, because of course the number of the cases. But I'm just telling you about different ways that you can make the results more reliable. The results we had, they were reliable, but just in case they were sometimes above and sometimes below, let's go and try it with 10,000. Now the average and standard deviation you see are based on 10,000 simulation, and when I refresh this, okay, you see the type of average that you see, there is less volatilities. You don't see 1.2, you don't see 2.2, similar to the previous one, because now we have 10,000 and it is more reliable. Mostly they are around 1.5. That's the reason I say in special cases you can tackle the problem in a way that gets you to the answer you want.